Hi, good evening, everyone. So I guess I'm the speaker that stands in between you and the after party. So I'll try to try to keep it a little quick. Um, so yeah, I wanted to talk to you about a cute demonstrator that we created, a consumer electronic demonstrator, and also demonstrate it very quickly today and talk about our experiences in developing this demonstrator. Yeah, and hopefully I would be able to take most of your technical questions. Little caveat: I'm not the person who's designed or developed it. It's my colleague. Unfortunately, he yet hasn't been able to travel to Germany. So maybe I won't be able to deep dive into your technical questions. So thank you. And yeah, a quick introduction. I'm Sumer Bains from Verolt Engineering. We are a UK headquartered engineering services company with, yeah, essentially our backend is from India, from Bangalore and Pune. I come from Bangalore in India, and part of our team sits out of Pune. So we develop our classical automotive software, the ECU software out of Pune, and the application side and the HMI development is something we do out of Bangalore. So great. So about the HomeChef application. So a little idea how this demonstrator came up. So the idea was to showcase various cute technologies coming together. Yeah, and the scenario we thought of was a consumer electronic scenario and related to cooking. So the idea was then we thought of, okay, what could the future scenarios of smart cooking look like? Yeah, so there would be definitely a smart cooking device involved in the scenario. It would have reasonably good user interfaces, fluid flow from the interfaces. Users would assistance to happen. They would like that they wouldn't be able to always touch the interface, so they may want to just use voice to control some of the devices. And yeah, everybody would like some sense of web enablement in the device. You may want to look at videos while cooking a recipe, or you may want to watch podcasts. Yeah, then you would want to, of course, search recipes. You may want to plan your meals for today, for the future, for the next upcoming days. Check your nutrition content of the meals that you've planned. Check how your monthly, weekly nutrition scores have been. And another scenario could be that you may want to see live from your devices what's happening. Yeah, so imagine a smart refrigerator where you may get the ingredient list or the ingredient view live coming from the device with it telling you what's where and how much of it's available. So, and of course, you always would prepare your shopping list. Yeah, so you would need these scenarios to be addressed by a smart future cooking. So, and where would you do it? Yes, of course, a large element of this would happen in the kitchen, a smart device in the kitchen. You would have your recipes and meal planning done on your laptop. And you would have maybe your mobile phone to get your real-time shopping list prepared and also do some meal planning on the mobile as well. So with this in mind, we then got down to started making this demonstrator, and what it's resulted is this. So, sorry, just give me a second. I have some. Yeah, so you can see we have on the top left Linux-based hardware running the HomeChef application, where you have your entire cooking being run on a Linux hardware. It's simulating a smart device with these very nifty controls and animations. On the top right, you have Qt for WebAssembly. Yeah, so this application is completely developed in WebAssembly for your meal planning. And in the bottom part is the mobile application, again developed in Qt. So this is what the demonstration or what the demo idea is all about. I'll take a few minutes now to actually showcase the demonstrator to you. So just need a little help here. Somehow I seem to have lost the, one moment please. Function. Should I just reconnect and see? Yeah, okay, great. So as I mentioned, the one aspect of the demonstrator is an application purely in WebAssembly. So this application that has been developed is a complete WebAssembly application. Yeah, it's running on one of our servers, and you have your recipe book, you have your shopping list, and your nutrition aspects here. So I'll just quickly showcase each one. So assume this is your recipe book. You have a huge set of categories of recipes available. You can deep dive into it, see the Nutri-Score for it, and what we've developed here is some little nifty animations using Qt Design Studio. Yeah, so all these micro animations you see in the WebAssembly are all done in Qt Design Studio, and we just developed the desktop application, build it for WebAssembly, and deployed, and it kind of works seamlessly here. And you could send this to the embedded device, and this way the meal plan goes to your device. And I also show this in a minute. You can add the recipe to your shopping list. Yeah, and these widgets that you see here are done in Design Studio as well. Yeah, so you can look at your shopping list here. You can look at some ingredient, update it. The same shopping list goes to your mobile app, and it gets updated there as well. Say you already have this ingredient, then you can just choose to remove them from this list, and they go to your, I have a massive already have list, so I can take them back and make them as live ingredients. Yeah, so all developed in Qt Design Studio, developed on desktop, and then built for WebAssembly here. So the performance and others is what you can see here. Pretty good in performance and very consistent. So that's the absolute benefit of having WebAssembly. And also you can see that the design is quite reactive. Yeah, as I minimize it, you can see that the UI elements scale up and scale down based on the size of the view, and this is something you would expect from any web application. So you have that and good performance on the Qt WebAssembly. Yeah, this application here that you see is what we have running on the Linux hardware. This is the embedded application. I also have it running on the Qt for MCU if someone would like to play with it later. And so here you have your recipe books, the same stuff. You have your ingredients, and you have your meal plans for the day. So I had sent this from the application, and you can you receive it here. You can start cooking. This starts showing to you. You know, these animations are something which a smart cooking device would have. Yeah. All these animations that you see are designed in Qt Design Studio using the timeline feature. Yeah. Yeah. Okay. Yeah. So the play video recipe is something I have it. If you come down to our demonstrator section downstairs, you could have a look on the Linux hardware that the play video recipe actually launches Qt Web Engine, and you can watch the YouTube video of this recipe coming in from the Web Engine rendering. So I don't have a desktop version of it. There's certain limitations of running the web engine on the desktop. Yeah. Yeah. So this is the embedded hardware and the WebAssembly application running here. Yeah. So great. So I'll now deep dive into a little bit of the technology aspects of the demonstrator. So the idea behind the demonstrator, the choice of technology used was also to do with the choice of deployment scenarios. So we had all the three applications, the desktop or the WebAssembly, the mobile app, and the hardware all communicate via MQTT. Yeah, so that was also a Qt module that we used, Qt MQTT. So we had two scenarios here, one in which we use a public MQTT cloud server to make the three applications interplay and exchange data between them. And the other was a scenario in which we had the MQTT broker run on the Linux hardware. Yeah, so that's maybe in a scenario where we don't have an internet connection and we need a local deployment between the three. In that case, the mobile phone can act as a hotspot, and you can connect the three devices and have an interplay happening. So with these deployment scenarios, I talk a little about what was the technology that went into each of the devices. So on the left, you can see the embedded Linux hardware. So this was IMX6 based IMX6 dual hardware that we used from Gaz and Fricke, a Santara device. It had Qt Web Engine on it for running the videos, the YouTube videos that I mentioned about. Qt WebGL for showcasing. If you look at the demonstration below in the section, you can see that the camera view is streamed via Qt WebGL. Yeah. So we have a camera connected to the hardware below, and that information is streamed via WebGL. Qt MQTT, the client-side communication, we have a Mosquito MQTT broker installed on the hardware as well, and Qt web server. The web server makes the Linux device also serve the WebAssembly pages. So you don't even have to install them on a cloud. You can even make the hardware act like a web server here. The latest thing that we got working was Qt for MCU. So that is Qt Ultralight, and I'll talk about it in the subsequent slides. The desktop was WebAssembly development, and we of course had Qt MQTT client also used in the WebAssembly application. As you know, there is no direct access to TCP/IP or ports on the browser, so we had to use the WebSocket or Qt MQTT over WebSocket to enable our communication there. And the mobile, well, we built applications for both Android and iOS versions, and these also communicated via MQTT. So we used Qt Design Studio and Qt Creator extensively in developing these applications. Yeah. So this is about the demonstrator and the technology that went behind it. I'll also share a few experiences that we had with the WebAssembly, with Qt MCU, and the Design Studio now. So yeah, the goal, of course, when we started developing these three applications was to maximize the reuse of our UI elements as much as possible. All the widgets you saw, the Nutri-Score widgets, the dials, the graphs as well, all had to be reused between the embedded device, the mobile device, and the WebAssembly. So the Design Studio was extremely helpful in our development efforts here. So we had to support multiple layouts, multiple screen resolutions, and it was extremely easy to do that using the Design Studio. Our initial development for the dials and the animation when we were not using Design Studio was very primitive, using raw Qt Paint rendering to make the gauges animate. But with the timeline feature of Qt Design Studio, we accelerated all the animations that you saw happening very, very quickly. So all the dials, the charts, and the graphs that you saw animating were all done in the Design Studio. Another very important, at least from an effort point of view, while developing, was the Photoshop bridge in the Design Studio. Yeah, so I believe per screen we must have saved at least a week's effort. Yeah, the fact that we could go from importing, the assets in Photoshop to getting the QML out saved us at least 1 week per screen in terms of effort. So extremely beneficial for us. Yeah, but there are of course certain things that we would like the Design Studio to incorporate going in the future. It's still some help we could get. There's a lot of so moving from Design Studio to Qt Creator takes a lot of manual effort. Yeah, there's a lot of asset copying to be done, and it takes a lot of effort. Yeah, so if the transfer from the Design Studio output to Qt Creator was a little more seamless, then it would really help in development times. So even components like timeline and other to Qt Creator could be made much easier. So when we want to develop stuff in Design Studio, let's say an instrument cluster panel or something, it would be nice to have certain plugins. Yeah. So for example, canned data to simulate how the look and feel of the UI would be. Rather than develop some C++ backend or some plugin to get data from somewhere else. So if we could not develop C++ backends to drive the data, but just have plugin support for canned data and better simulation environment, that would really accelerate our development times. And since we have a little bit of leaning towards automotive at Verolt, so infotainment and instrument cluster is something we are deeply focused. So as we look at the Design Studio currently, we feel that multiple theme developments going forward from the Design Studio would really help in creating good infotainment and instrument cluster applications. So the latest Qt for MCU development, yeah. So it's right now kind of standalone when you try to develop Qt for MCU. So it would be great if that also gets support inside the Design Studio. Photoshop. So this is something very technical, and of course, some developer of my team has felt that quite a bit of pain in achieving scalability through the Photoshop bridge, and I believe this is true. So when you import and if you have to support a project like this where there are different screens and different resolutions, and if everything's in absolute pixels, then it's a nightmare for the developer to keep making them relative in terms of screen size. So that would be something really nice to have very quickly, I guess, as well, to reduce a lot of development effort. Yeah, so the WebAssembly was something very new for us as well. We are very automotive and hardware focused developers, and when we started developing WebAssembly, we were a little apprehensive about it. But then, I guess there have been rather very interesting positives coming out from using WebAssembly. Yeah. One thing is, as you saw, the design is completely reactive, so you wouldn't know whether that page is developed in Qt, or it could be, thought of as being developed in any of the top frontline web technologies like Angular or others as well. So it really gives a very good look and feel while developing in WebAssembly. And one added advantage is that, when you're developing, you can share your prototypes with your customers very quickly rather than share executables like your desktop executables or other binaries. All you need to do is build on desktop, deploy it as WebAssembly, and just share a URL with your customer, and it's easy for them to look at the application running at their end. So that was something, very very good for us when we were developing all the three applications. So yeah, as I said, you get real-time feedback from customers with WebAssembly very nicely. So WebAssembly does support multi-threaded. So we enable multi-threaded, but our application is not so heavy, so we don't have yet benchmark numbers whether it really improves the performance. But it should be, yeah. So and it supports Chrome, IE, and Firefox. I did see in today's Google presentation in the morning on Chromium that it supports Safari as well. I didn't think so. So that's an interesting update then, which may have happened. Yeah. So yeah, overall the ease of development is great. So of course you have some build environments to be set up. You have to deal with a lot of mscript and cross compiling to deal with. But once it's set up, then you can just take any Qt application and easily build for WebAssembly. Portability, there are multiple aspects to portability. I guess why we rate it higher is, of course, the support on multiple browsers. At least the application we developed runs on 3 out of the 4 major browsers. Performance as a standalone application is very good and very consistent. So the same application running, you really see no deterioration over time. You see extremely consistent behavior with every click, with every scrolling behavior, with every widget's behavior. So it's extremely consistent. A little perhaps concerns I'll highlight in the next slides are with the compile times. Yeah. So some things which were perhaps a little limited for us. There are some restrictions, of course, when you deploy something in a browser environment, like file access and port opening, which is not available when you build the same application for WebAssembly. Yeah, so our embedded application, which has a lot of file access, file IOs, just is not completely portable onto WebAssembly. But if you've heard what was said in today's presentation in the morning, the next versions of WebAssembly come with a lot of IO as well. Yeah. So with that, I guess then portability of your Qt applications onto WebAssembly would be 100%. But these are minor glitches right now. I guess it's just because of security it's been disabled. There's no other reason of disabling it. Yeah. So the browser accessing the local file system would need to be taken very seriously. Yeah. So while developing, of course, since it was the browser application, we spent a lot of time sorting out one issue with getting MQTT communication through the browser. Yeah, so it had to be done over WebSockets, but there seemed to be some major bug on Enscripten side, which didn't allow it to happen. And thankfully, folks at Qt patched it up at their end, and we were able to get it running. So that, we lost some weeks trying to figure that issue out. So the application compile time, so that's the time to build your application is high, yeah, but that would get sorted out as better compilers come out in the future. Client-side compilation was high as well. So when you run your WebAssembly on your browser, the time it takes to compile, it really varies. I say 1 to 3 minutes here. It can be a few seconds also, but this is something we have seen on an average happening with our application. Yeah, I guess this is something that would improve going forward. Thank you. And binary size, well, not really would be a big concern since you're going to be deploying them on servers, but then this also gets downloaded onto your client side and then gets compiled. So it may be something to watch out for and have some more optimizations on the binary size. So currently our application that you saw is about 17 to 20 megabytes. Yeah, so this may be something that we keep an eye on in the future and hope that there are some optimizations on at this end. Great. So everyone's heard about Qt for MCU, and we also developed the same application that ran on the Linux Cortex A9 hardware, the extremely powerful hardware. We also got it ported onto this very small footprint MCU, and I run this video so that you get an idea of how the UI looks like when running on a small MCU. So in fact, the scrolling behavior and certain animations on the MCU are far smoother than on the extremely powerful Cortex A9 processor. We don't have yet exact statistics why this is happening or deep dive, but this is running on bare metal, and it's an extremely light Qt framework as well. So these all are adding to rather good performance on the UI side. Okay, so I just check. I hope it's.
I have a question. Why you make both applications with the Linux and the bare metal?
Yeah,
Just to make your choice?
I'll just come to that. Just give me a few minutes. I'll take that question. Yeah. Good. So yeah, so the Qt for MCU development was done on a small Cortex M7, the STM Disco. Our application size was 10 MB, a little high, but this also includes all the images. Yeah, so the final hex image size was 10 MB. And it was a quick 4-week development. Actually, I was in Germany last month, and the team just quickly developed. And I also have the hardware for the first time today, seeing it. Yeah, so it just took us 4 weeks to develop the complete application on Qt for MCU. Yeah, so that was quite good. Yeah. To developers 4 weeks was the effort that we spent. Yeah, so but yeah, not all smooth sailing. Yeah, so there's quite a few challenges in getting the MCU story sorted out. So just for the developers on QML who would like to understand what were the challenges we faced, these are a few of the things that in the last 4 weeks we experienced and how we sorted them out. Yeah. So I mean, I won't go through all of them, but I just give a quick example. For example, the second one that you see, the rotation not working. For us in Design Studio, it was a timeline property set, and we got the feature out. But here, there was to get the dial to rotate, we had an image behind which had to be rotated with a timer. So a bit more manual work done. So the QML has to undergo a lot of changes to get it running. So as I mentioned, I have the hardware here. I would leave it on the table if you would like to play with it and have a look at the performance of the MCU as well. Yeah, so that's all from my side. Thank you a lot for your time and patience, and I would take questions. Yeah. Yes, your question is still the same. So the original idea was, of course, when we started, there was no Qt for MCU available. So we started with the slightly more powerful hardware, but at the end, the plan was also to have a complete voice assistance also running on the hardware. Yeah. So we chose a little bit more powerful IMX hardware just to make sure that we could run a speech assistance as well as the main application. Yeah.
And how bad was not using Design Studio for the MCU? I mean, is this something that you really miss?
Yes. So if you because we started first and had a full functioning QML developed for the Linux hardware, so it was kind of easy for us to make changes to it and then get to the MCU. Yeah, but if you were perhaps starting from fresh with this kind of a UI, not having a Design Studio, may not be wouldn't be such a good thing. Yeah. Sorry, I do not have any specific instance I can tell you right now. As I mentioned, I just received it as well. I was just traveling the last 3 weeks, so I haven't seen the development process of the MCU. I just saw the final output today. Yeah, so I can perhaps check with my colleague and let you know about it. Yeah.
Hi. I didn't understand very well the client-side compilation for WebAssembly. It means that the code is compiled to bytecode like a regular compilation, and then when you open the web page, it has to be recompiled again by the browser?
Yes.
And it can take 1 to 3 minutes?
So yes, it does take, but it's also that the files have to be fetched from the server, so it could be there's a delay that adds to the time, and then of course it's the compilation time as well. So when I was running this application in India, I and our servers in France, so I don't know if that played a role. Today, since I've been running it since morning at the demonstrator set, it's been loading in 20 seconds, or sometimes even in 3-4 seconds. So it raised a lot of questions as to why did we observe 1 to 3 minutes earlier. So we assume it was maybe the file transfer was taking time, and therefore it had this much amount of delay.
So it's more the time to take to download the file than the compilation?
Yeah.
Okay.
Yeah.
Thank you.
Okay, we're a little bit over. Unless anybody, we could take one more question, or anybody else? All right, thank you very much.
Thank you.